And the circular economy right now, there's still too much which is done in a take, make, break fashion and then thrown away. But when we look out in nature, we can see that there is no waste. Everything is reused and everything is of value.
We really need to transform the current agricultural practices because we are currently degrading a lot of the soil globally.
In a future bioeconomy, all what we eat, use, wear, build and live with needs to come from sustainably sourced biomass. And in order to make that happen, we need flexible multi-purpose biorefineries that integrates mechanical, biological and thermal technologies and produce multiple products at the same time. In Northern Europe and especially in Denmark, what grows really well is perennial grasses and perennial legumes, clover grass mixtures. It is highly productive. It has a very low environmental impact, low nutrient leaching, build-up of carbon in the soil, and it also produces a lot of protein, which we are in a big need of. So using green perennial biomass for biorefinery is a really good opportunity for future bioeconomy.
We need not only to reduce our CO2 emissions, we also need to take CO2 out of the atmosphere. And one of the simplest low-tech ways of doing this is by photosynthesis by the plants. And perennial cropping systems, they are able to be green and take up CO2 from the atmosphere via photosynthesis during a longer time of the year. This means that they take up more carbon, which can either go into the soil carbon storage, or it can be harvested to be used. Perennial systems contribute to the green transition. We can produce a lot of biomass during the entire growing season.
Plant cells have very tough cell walls. There's a reason why we don't just go to the field and eat grass directly from there. There's a high amount of fiber, and if we just eat that, we would get a stomach ache. So we need to do something to take out the protein from these plant cells for us to be able to digest it. It's very important not just to focus on the food protein regarding these biomasses, because it's only a small part of it that will actually go for food. We have a huge fiber fraction. So one could imagine that when we do a biorefinery process, we do this fractionation, getting a fiber-rich fraction might go for feed or maybe even textile. And then we have the protein fraction, the soluble proteins, where we'll separate it into a green-colored protein and a white protein, which again could go for feed and food. And then, of course, leftovers might go for biogas or something. But it's very important to use the whole resource. There's a huge potential here because it could be done more or less all over the world. For example, with the clovers and grasses, we have the seaweeds. So both the green and blue biomasses and also the CO2 to protein, where you can put up bioreactors without having a huge requirement for farmland. So in this way, there's a huge potential.
Mussels and seaweed have the capacity to take up nutrients from the marine environment. The mussels, they filter out phytoplankton, and phytoplankton take up nutrients. And the seaweeds, the macroalgae, they take up the nutrients directly. So this means that these two blue biomass crops, so to say, they sort of take up the nutrients that we wash out from land and enable us to pick them up and then return them to the food web on land. So that sort of closes the circle between the land and the sea. One of the major challenges here is that, as there is on land, there's a big competition for space at sea. So we need to define the areas where we can get the best biomass and also the best services to the environment. If we can do ocean multi-use and in the wind farm areas dedicate 10% of the area to production of mussels and seaweed on a global scale, we can enhance the aquaculture production, the low trophic aquaculture production by 37%. So that there is a big potential of scaling this up, but we need this scaling of the production needs to go hand in hand with the scaling of the processing and the products and the use of it.
In order to engage a lot of different stakeholders, it's always super important to think about both what's in it for me for an individual stakeholder, but also what is a common ground for the different stakeholders to collaborate with each other. Because we are talking about circular economy business models, and we are talking about industrial symbiosis, meaning different types of industries are collaborating in a symbiosis just like in nature. The importance is to emulate nature in this way and use everything.
Every innovation, to have value, it actually needs to be established in society and at scale. So for an innovation to actually make it as a new product onto the shelves in the supermarket, it's vital that the entire value chain is engaged. And this means that consumers need to see a value in the new product. Producers also need to see a benefit to a new production method. And legislation really has to aid in this process of implementing the product.
In Denmark, we have been working intensely on developing these concepts over the last decade. This is the biggest demonstration platform for green biorefinery in the world, and we have the opportunity here to test at industrially relevant scale new technologies, new technology integrations, and new value chains. I want to make a difference. I want us to make new solutions that can benefit society and build something better than we have.